Now let's look at a 1D signal and start thinking about how would we actually reconstruct a signal based on the information that's available to us. Here is a signal. It's basically in one dimension, and it's a repeating impulse function, which basically means that this function is 0, and then all of a sudden there's a peak, comes down, peak, comes down, peak, comes down. So in the 4 times, it repeats. So this is 4 different periods. Whenever it hits point 1, 2, 3, and 4, it repeats and hits a magnitude of 1. So that's why it's referred to as a repeating impulse function. What we're interested in is if this is my target signal, how would I go ahead and reconstruct it if I knew anything about this signal? To help us do this, let's create a building block. The simple building block we want to actually use here is this function, which is a cosine, where A is the amplitude and omega here is the frequency. So just by varying the omega and the times of omega for a specific A, I want to be able to generate a function f, and I want to be able to see if I can actually use this to start creating or recreating a signal like this. So we're interested, of course, is using a function like this, where we can vary the n omega, the frequency. Time is, of course, the variable that goes in this axis. And of course, we want to be able to go, in this case, an amplitude of A, which is 1, and generate a signal like this. Any thoughts on how we would do this? Well, let's get into it. So if you just remember some of your earlier math concepts that you may have studied in past, what we want to do is now create a repeating signal that goes and has 4 periods. And it goes from, in this case, 1 to -1, back to 1, -1, back to 1. And basically it's repeating. And of course, this is an output of this cosine function, where t varies from 0 to 4 here. And we're changing omega. Now, of course, if you know anything about sines and cosines, you know that if this term here is going to be a specific value, the value of this one will be 1. So, of course, that basically means in a repeating circle like this, we're basically changing the angles. And of course, sines and cosines of these angles are being computed and plotted on this thing. So let's look at variety of these things. F1 was when we basically just replaced it and we basically had this value. Now, in this case, I would claim n was 1. What happens if I make the n 2? So replacing the n value to be 2 with the same omega and t, we now basically are getting twice as many repetitions for the same period. So now, of course, this is higher frequency information. We're getting more signals and peaks and signals coming in than we did before. Here is basically now, I've basically gone for the n value of 3 and repeated the signal again. So the more frequencies are coming in. Here, of course, F4, again, higher frequency. So in essence, what we've done is we've gone from low frequency information to high frequency information here. Now let's look at all of them together. This is the F1, F2, F3, F4. Before we go on further, let's actually introduce a way for you to play around with the similar kind of concept on your own, on the browser, or on MATLAB, or in OpenCV.